Hello guys, welcome to this lesson. Today we are looking at authentication fundamentals for APIs. So we'll talk about identity, trust and access control. If you're new here, you're watching a lesson which is part of the series Building Secure, Scalable, Fault-Tolerant and Low Latency APIs with Java and Spring Boot. My name is Ngane Emmanuel and I'm your course instructor for today. Well, for all of the course actually. So let's recap what we have done so far. In this course, we have introduced the concept of APIs. We've built a basic API. We've learned about injection attack. We've learned about securing object by binding with details. And now we are trying to control identity and access. All right. So authentication answers the question: who is making the request? So the learning objectives for this course is that by the end of the lesson, you understand authentication concepts, differentiate authentication from authorization, learn common authentication approaches, understand password security basics, learn token-based authentication concepts, and understand trade-offs and risk. Right? So the links to the GitHub repository is found in the description below, alongside my social media contacts for you to connect with me and let's talk about software engineering stuff. Also, if you have comments anywhere or even for past videos, please don't forget to leave them in the comment section. I'll get to it as soon as I can. Like, share and subscribe to the channel. Also click the notification bell for when I upload new material. If you find this interesting, I encourage you to stay to the end, and we're going to move to the actual lesson today. So authentication versus authorization. What is authentication? So authentication answers the question, who are you? Okay. It allows us to protect our system by asking the user, who are you? So examples of authentication is username and password, token-based authentication, certificates, and biometrics. So if you've ever tried to open your phone and they ask you to scan your face, or they ask you to put your finger for your fingerprint, or they ask you to add your username or your password, then that entire process is called authentication. You are trying to authenticate your identity. Are you the person that has this particular device? Okay, and in a system, the question is, who are you in this system? Are you a part of this system? That is what authentication is all about. Who are you? Authorization, on the other hand, though they often work together, answers the question, what are you allowed to do? For example, you gain access to my mobile phone, or someone gain access to your mobile phone. What are they allowed to do in your mobile phone? So it's not just who are you, but what are you allowed to do? Authorization asks what roles, what permissions, right? What authority do you have in the system? So example of authorizations would be role-based authorization, permissions, and policies. Common confusion. Authentication and authorization solve different problems, right? Often they work together, but authentication answers who are you, while authorization answers what are you allowed to do in that system. You must authenticate first before you can authorize. Example, a user can log in, the identity is verified. That is authentication. The system then checks the role that a user has and asks, what access level do you have as this particular user? Depending on the access level, the system grants access to certain actions and certain resources. That is authorization. So mixing these concepts can lead to insecure designs. So why do APIs need authentication? Without authentication, anyone can call an endpoint. Okay? You can have data exposure, abuse and automation in attacks such as denial of service attacks. No accountability is when you don't authenticate a user. When anything happens, you don't understand who did what, no audit trail, what is being done in your system. So public APIs are still required to identify and track. So trust boundaries. So what does authentication bring? Authentication establishes identity. It establishes trust levels, accountability, and traceability. It allows you to identify who in a system. It allows you to say this person is okay to perform this certain action. That's trust. It allows you to say this person was the one that performed these actions yesterday. That is accountability and traceability. So, common authentication models, right? What are the different kind of ways we can authenticate? So the first one is basic authentication, which was the most common at the time, but it is not the most recommended. It is basic authentication. Username and password sent with every request. So for every request you make to an API, you send your username and password so that it should be used to authenticate you as a user or as a service that has access to this particular API. Simple but insecure unless you use HTTPS, unless HTTPS is enforced. Even HTTPS is being enforced, it is still not the most recommended procedure. At least it is used often, in fact everywhere, but it is often recommended that you use more than one or not rely only on basic authentication. Limitations will include credentials being exposed frequently. People can have access to your username and password, right? Hard to revoke. It is difficult when you use your username and password for someone to close your session when you're using an API or the platform, right? It is hard to revoke that access because by authenticating, you just have access. You can do a lot of things with your username and password, and it scales very poorly. You cannot really scale it. Okay. Now, the second model is session-based authentication. This one was also really good. It's still widely used today. And essentially, the server stores the session state. When you authenticate yourself, the server stores your session state. And then the client stores the session ID in the form of a cookie in the browser. All right. So if you've gone to websites and then you log in, sometimes the authentication mechanism is a session-based authentication mechanism, which is why sometimes if you say you clear your cache, and then that includes your cookies, or you come back to authenticate within that particular site, even if you were just there, it will require you to log in again. So this it's common and in traditional web applications. Again, it is most frequently used. Limitation: it is hard to scale horizontally and requires sticky session or shared cache. Now, the next one is called token-based authentication. Sorry, it is among one of the best that is most frequently used in recent authentication mechanism, and it is one of the most advisable to use. The server issues a token after login. So yes, you're going to use your password and your username, or your username and your password, or your email. And when you send a request to the server, to your API server, what happens is that the server is going to now create an authentication token that is going to respond to your client with that token. That client then takes the token and saves it in a secure manner. Then for every request that client intends to send to the API or to your backend, to the server, it has to include the authentication token in the header. It is that authentication token that is used to authenticate that request, saying that this request is coming from a trusted source and has this and so role or access. So the server validates the token. So common types of token-based authentication is JWT, very widely used, OAuth, which is also very widely used, and access tokens. So the benefits of token-based is that they are stateless, they scale very beautifully, horizontally, they scale easily, and they are very cloud friendly. In fact, they are the most widely used recently. Even new applications and old applications are switching to this particular token-based authentication. And it's easy to end a session, unlike in username and password, and it's easy to close a session when vulnerability is being detected or a hack is being detected on the user's side. So the other model for authentication is called API keys. Now these are static. Static keys, and they are issued per client. Right? They are used mostly for service to service or public APIs. For some of you who are developers, you have used ChatGPT. You have like the GPT API keys. You have used the Google. You have like the Google API keys. Even if you want to like include the maps, essentially these are services that allows other services to request the certain usage of them. So they are mostly important for service to service communication. If you're building something like a SaaS with an endpoint, you might want to, and then you have like a shared API, which you only share with some businesses. Then each business will have like an API key, and that API key allows you to track the user, authenticate the user, and also allows for accountability. So the limitation is that they have weak identity and hard to rotate, often leaked. Yes, API keys are often leaked because, especially when you're encoding, they tell you one of the very important information that they try to pass when encoding is how to properly code and keep your API keys even when you are in a collaboration on a project. And often API keys get leaked on like a GitHub repository because there is a mistake from a particular developer, be it a fresher or a junior or a senior. Those mistakes happen, and often those keys can be abused by attackers. So that's one of the problem of API keys. Then we have password security basics. Right? So these are some tips of password security. So the thing is, the first one, never store plain text password. So password must always be hashed. So that's the definition of hash. Hash is converted into a one-way mathematical value that cannot be reversed. So the password can also be sorted. So a random data can be added before the hash to prevent duplicate and pre-computed attacks, right? And we also have they have to be stored securely, safe with restricted access and encryption, never as raw password. Very important. We'll see that particular one. Most of the time, we're going to use like bcrypt, but you also want to avoid certain hashing algorithms such as I think is it something 5? Forgotten how but we'll see it here. So hashing versus encryption. Hashing is one way, encryption is two ways. Okay. So encryption, you can encrypt information. It's going to give you some random text, some gibberish, and then you can decrypt it as long as you have the encryption key. So passwords should be hashed, not encrypted. So secure hashing algorithms are bcrypt, as I mentioned, Argon 2, and script. So you want to avoid MT5, yes, and SHA1, and there are some other few, but most of the time for Spring, we're going to be using bcrypt. So password attacks. So attackers attempt brute force trying many password combinations until correct one is found. And you want to prevent this by limiting the amount of tries. As you have seen, some of you have been on websites where you try password after like 3 wrongs, you cannot exactly access the login form again. They kind of prevent you and forces you to reset your password through your email, and then they send you an email and then tell you that someone attempted to enter your site. And so that person, so that's like brute force kind of the idea. They try multiple combination of words or letters or characters in the hopes that they finally land on the correct one and gain access to your site, your account or your API. So credential stuffing, using leaked username password pairs from other sites. So sometimes I don't know if you have gotten this where you log in maybe into your Google account or some other account, and then they tell you with a single message that you should change your password because your password was found as one of the leaked as a leaked password on a particular breach that just happened. Okay, so what happens is that these particular passwords are being leaked on popular sites that some people go and farm and they take and they try on on different websites, and they hope that they can gain access. We have rainbow tables using pre-computed hash database to reverse weak hashes. Again, you want to use very strong hash algorithms. So if you use like MD5, it's now kind of very possible to reverse an MD5 hash. So we have phishing. So again, this is a cyber attack that gets to do with tricking the user to revealing their credentials through fake interfaces. Even through email. Or your Facebook, somebody tricks you and tells you that, hey, your account has expired. Click this link. You click the link, and then they send you a fake interface, and then you input your credentials thinking that you're on the real interface, only for them to get your account. And a lot of people, especially on social media, are losing their account because of this particular technique. So you need to defend against this by educating yourself and also apply layered protection such as two-factor authentication. Also, you need to ask certain questions. Okay, although I did not put it here, but sometimes depending on what you're building, you need to look at the different W's. I think it is you need to ask in your authentication, like password, username and password. Ask who are you, right? You also ask what are you? Are you a robot? You need to ask like that to prevent something like DOS attack. So that's like a captcha to prevent those attacks. You also need to ask something like, where are you? Right? Have you ever, I think sometimes you've noticed like you're on Facebook, you continuously log in, then when you change like a location, out of a sudden your session expires. And you're asking them, you just logged in somewhere, but what happens is that you kind of moved away from a particular geographical range, and now they're like asking, where are you? Or when are you, your time zone, or something like that. And there are different ways um, to check and validate. So you want to really put in layered protection such as biometrics and two-factor one-time password like OTP and different security measures. So token fundamentals. What is a token? We've mentioned about token here. So a token is a digital proof of authentication, right? It represents user identity, claims, expiration, and integrity. So JWT token structure, conceptual structure. So we are going to use JWT here. And a conceptual structure of a JWT will consist of the header, the payload, which contains the claims, the signature, which is what you use to sign the token, and what you're going to use to verify that that token is signed by your system, right? And then the JWT, so the JWT is signed, not encrypted by default. Okay. So token life cycle. So the user logs in, the server validates the credentials, the token is issued. So when the token gets issued here, it returns it to the client stores the token now gets sent with each request, and the server validates the token to process the request. The token expires, and usually you want to keep tokens to be very short-lived, usually like 2 to 5 minutes, maybe 10 minutes depending on what you want, but usually they advise around 2 to 5 minutes maximum. And you want to have like a refresh token that allows you to refresh your token. The mechanism is what you use on like on Facebook. You don't have to log in every time. You use tokens because those tokens get refreshed, they get they expired every given period of time, and your device automatically sends a request to refresh those tokens. So you don't see it, but it's very important. So security risk, token theft. Okay, so an attacker steals a valid token and uses it to impersonate a user. So That is a common one. Token replay, right? You capture a token, somewhere you get a token, and then you will use it to repeat an authorized request. So someone sends a request to do something, and then you somehow get the token, and then you retry that request with that token. So token leakage, tokens are accidentally exposed through logs, URLs, or client storage. Again, yes, if you're coding like with most of these JavaScript, and you have to, even on web browsers, you have to store your tokens, right? They kind of advise you not to, I think, store it on local, not to store it on local storage because it gets leaked. They can use different methods to extract your token on your browser or on your local storage, and it's advisable to store it more securely. And long expiration window. I spoke about expiration window is that you should always keep your tokens short. They should expire maximum of like 5 minutes, and you should have like a refresh token which is only used one time to refresh that particular token. Okay. Stolen tokens remain valid for too long, increase damage. So if your token remain valid for too long, like an hour or two, if someone steals that token, then they have about an hour or two to perform whatever catastrophic action they want to perform. If you keep it within like 1, 2 to 5 minutes, then they have just about that time, and it limits their damage, the damages. You also want to defend against this token risk by shortening the expiration. They spoke about that. And you also want to use HTTPS everywhere to prevent interception and token theft in transit. Again, that's kind of clear. So secure storage, I've spoken about that. Never store token in URLs or in secure client storage. Again, you want to store them in a very safe place. So token rotation and refresh reduces reuse. Again, I've spoken about token rotation, refresh, and replay risk. So if you refresh a token, someone cannot take your expired token and try to reuse it. Okay. Audience and scope validation ensures token are used only for intended services. So like you have to like your role of that particular user within the claims, you can include all of these things there, so that the token have just a valid particular permission to perform certain actions. um, Revocation and monitoring, detect and block suspicious token usage quickly. So yeah, if a token, say someone signs in with a token here, and then another person takes a token and signs in from another device, you want to like prevent that particular request. If a request is coming from two different destinations, like I said, you want to look at device, like the source of the request, more than just the server. You want to look at the device, the location, and all of this stuff. And that's how you're going to use to detect suspicious activity, right? You're going to use to detect if maybe a token has been stolen or something. So it's kind of like important. So security risk, password risk, weak password we use across sites, phishing, and database breach. Those are self-explanatory. Again, database breach, this is a very common one, especially when we look at social media. Sometimes you hear a report that Facebook has been hacked, this particular information has been breached, and then you see people receiving information from Facebook to refresh, to update their password, and something like that. So it's a very critical risk in the security area. So transport risk on encrypted traffic. If you're using basic HTTP, your passwords will be displayed clearly. So, but if you're using HTTPS, then that particular password and the user and the information basically from that for that form is encrypted. And even if someone performs like a man-in-the-middle attack and gets your credentials, what happens is that they see gibberish. They cannot exactly use it. Okay. So security versus performance. Obviously, security cost, right? When you do authentication, you have processing overhead. You have that the hashing and the encryption. They all costs, and the validation. They all cost processing. They all cost time. And you have, again, like I said in past videos, I think that video talk about trade-off. It's all about trade-off. You are not aiming for the maximum security. You are aiming for the best or adequate enough security for your use case and your system. So again, password hashing, CPU cost, token validation overhead, cryptographic operations. Again, these are all time, the cost time and CPU. Why is it worth it? Identity protection is very important. Again, legal compliance in certain countries. If they audit your system and they realize that the error came from your end, then you probably go to prison and pay a lot of money. So actually in all countries, user trust, again, that gives more trust to the user. If you hear that your password is being hacked, your account is being hacked on Facebook, not because of you, but because they hack Facebook every time, or Twitter, or any other popular site, then your trust for that site falls down. Right? So, but if it takes like years before you have a security breach as it is now, then you kind of have more trust for that site. System integrity too is very important. So that is what we have for authentication today. In the next lesson, we're going to look at some practical sessions, and after that practical session, we're going to look at authorization. So what we're going to look in the next video plan, implement login endpoint. Although we had a basic login endpoint, we're going to try to implement it now properly. Store hashed passwords. Again, we're going to see encryption with bcrypt. Generate authentication token. We're going to try JWT authentication token here. Secure endpoints. We're going to secure the endpoints. We're going to look at public and private endpoints. I'm going to talk about that. And validate token on request. We're going to see demo on sending token with auth header, and then measure overhead. So the key takeaway for this lesson is authentication verifies identity, authorization controls access, tokens enable scalable APIs, password must be hashed securely and also stored. Security requires layered defense. Again, I spoke about not just implementing password or authentication, like there are multiple, there's the authentication, the required step for authentication is multi-factor authentication now, which is MFA, which basically requires you to implement different types of authentication mechanism just for a user to gain access to their account, right? Which is kind of the same thing. But for our practical sessions, we're going to look at basics. I think we're going to start with protecting from, we're going to try to authenticate the source of the request, which not with API, but just authentication of source. And then we're going to move on up there. It's going to be a couple of videos. I don't want to make them too long, so I'm going to divide them. So you just follow along, and I think you're going to enjoy it. So that said, if you have any question, please comment below, and I'm going to respond to you. Follow me on my social media, Ngane Emmanuel, on all the social platforms. Like my posts, I post a lot. Comment and share, please. Also subscribe to the channel, and continue to watch, and I hope that I provide value to you guys thus far and in the future. That's it. See you in the next class, and have a nice day.